Good morning, students. In the last classes, we discussed two laws of motions. Newton's first law of motion, Newton's second law of motion. Okay, what is the Newton's first law of motion? Every object continues in a state of rest or of uniform motion in a straight line unless compelled by an external force to act otherwise. What is the definition of second law of motion? Rate of change of momentum is directly proportional to the applied external force. Okay, so in today's class, we have to discuss the Newton's third law of motion. Newton's third law of motion. Newton's third law of motion is related with action and reaction. What is action? So here we are discussing the two terms, action and reaction. What is an action? Applied force is called action. Applied force is called action. Reactive force is called reaction. What is action? Applied force is called action when to do a work, to move an object, we have to apply a force. That force is called action. What is reaction? After applying a force, that is action, a reactive force occurs. That force is called reaction. Okay, so action and reaction. Third law of motion is related with the action and reaction. So Newton's third law of motion states that to every action there is equal and opposite reaction. So Newton's third law of motion states that to every action there is equal and opposite reaction. This is called Newton's third law of motion. For example, consider two objects. Object A and object B. When object A collides with object B, what happens? Object A collides with object B. This A applies a force on B. That force is FAB. FAB, what is FAB? Force acting by A on B is FAB. This FAB is called action. What is the action? A force is applied by A on B. That is called action. FAB is the action. So, to every action there is equal and opposite reaction. So, B applies a force on A in the opposite direction. that is FBA. It is called a reaction. Okay, so we know to every action there is equal and opposite reaction. When an object A moves in the direction of B and collides with B. When object A collides with B, what happens? There is action and reaction. Which is action? FAB. Force acting by A on B is FAB. That is action. At that time, at the same time, at the same instant of time, B applies a force on A, that is called FBA. FBA. It is called a reaction. So, to every reaction, there is equal and opposite reaction. Okay, so here FAB is equal to FBA. To every reaction there is equal reaction. So FAB equal to FBA. But it is opposite reaction. So this is negative. FAB equal to minus FBA. FAB equal to minus FBA. Action and reaction equal but opposite. Okay. So here action and reaction is an instantaneous process. Action and reaction occurs at the instant of time. So action and reaction is an instantaneous process. So action is on B, but reaction is on A. So action and reaction takes place on different bodies. Action and reaction takes place on different bodies. Now we discussed Newton's third law of motion. What is Newton's third law of motion? To every reaction there is equal and opposite reaction. Okay. What is the next term? Action is the applied force is called action. Third, reactive force is called reaction. Action and reaction is an instantaneous process. Then action and reaction takes place on different bodies. Okay, so what are the points? Number one, first point, to every action there is equal and opposite reaction. Second point, applied force is called action. Reactive force is called reaction. Third, action and reaction takes place on different bodies. It is an instantaneous process. These are the points related with Newton's third law of motion. Number one, to every action there is equal and opposite reaction. Applied force is called action. Reactive force is called reaction. Action and reaction takes place on different bodies. It is an instantaneous process. Clear? Okay. Then there are many applications to the Newton's third law of motion. What are the applications of Newton's third law of motion? Number 1, rocket propulsion. Rocket propulsion or motion of the rocket. Which is action? So, in the case of a rocket, action is in downward direction, reaction in upward direction. Okay. When ignition process starts, when the ignition process starts in a rocket, air moves in downward direction. That time rocket moves in upward direction. That is the application of the Newton's third law of motion. Rocket propulsion is the application of the Newton's third law. What is the working of a rocket? Okay, in rocket hydrogen fuel is used. Hydrogen fuel is used in rockets. Okay, when ignition process starts, what happens? A force acts in the downward direction. That is called action. Okay, so opposite to the action there is reaction. With reaction, the rocket moves in the upward direction. Okay, this is the application of the Newton's third law. Next is, when we apply a force on the floor in the backward direction, we move in forward direction. So Newton's third law helps us to walk. Newton's third law helps us to walk or to run. When we apply a force on the floor by the leg, okay, so there is a frictional force in the, okay, when we apply a force in the backward direction, we move in the forward direction. That is the application of the Newton's third law. Any other examples? Yes, when a bullet is fired from a gun. When a bullet is fired from a gun, gun moves backwards. That time bullet moves in forward direction. When we fire a bullet from a gun, what happens? A gun moves forward. Gun moves forward. That time, bullet moves forward. That time gun moves backward direction. Okay, that is called recoil of the gun. Recoil of the gun. So here a gun. Okay, when a bullet is fired from the gun, bullet moves in this direction. Bullet moves in the forward direction. That time gun moves in the backward direction. That is called recoil of the gun. These are the this is also the application of the Newton's second. Third. Okay. Any other examples? When we jump from a boat in the forward direction, we jump outside from the boat in the forward direction. Boat moves in the backward. Boat moves in the backward. These are the applications of the Newton's third law of motion. Newton's third law of motions. So we discussed the three laws of motions. Okay, just we can recall these three laws. Okay. So first law is related with the law of inertia. What is law of inertia or first law? Every object continues in a state of rest or of uniform motion in a straight line unless compelled by an external force to act otherwise. That means every object continues in a state of rest unless compelled by an external force, or every object moves in uniform motion unless compelled by an external force. That is the Newton's first law. What is Newton's second law? Rate of change of momentum is directly proportional to the applied external force. What is the equation derived from the second law of motion? F equal to ma. F equal to ma, or we can write F equal to m into what is a? V minus u by 2. Okay, this is the equation to find the force derived from the Newton's second law. Okay, using this law we can explain first law. Using second law we can explain first law. Okay, so here T is multiplied with the F. Ft equal to m into v minus u. Ft equal to m into v minus u. When f equal to 0, v minus u equal to 0. That is u equal to v. U equal to v. What is the meaning of u equal to v? Uniform motion. Initial velocity, final velocity same. When initial velocity and final velocity same, that means uniform motion. Okay, so we can explain an object continues in uniform motion if the applied external force is 0. Applied external force is 0 means if there is no applied external force, an object continues in uniform motion. In uniform motion. Or if f equal to 0, f equal to 0, v minus u equal to 0. V minus u equal to 0 means there is no change in velocity, or we can write u equal to 0. Okay. If f equal to 0, u equal to 0. That means if external forces, if there is no external forces applied, an object continues in state of rest. Okay. If there is no external force, an object continues in state of rest. If there is no external force, an object continues in uniform motion. This is the definition of the Newton's first law of motion. So, first law of motion is explained by using Newton's second law of motion. Then what is third law of motion? To every action there is equal and opposite reaction. Okay, so today we can conclude our class. Today we discussed Newton's third law, and just we explained Newton's first law, second law and third law. Okay, thank you.